Welcome back to the Enduron podcast. I'm Andy Oderzinski. I'm here with Davies Hood, and we're going to talk today about the origin of ceramic epoxy and why it's effective for applicators and owners. Davies, I was hoping you'd talk to me a little bit about the background of ceramic epoxy, how Enduron originally invented this material, learned it was special, and started deploying it through the wastewater market.
Ceramic epoxy is uniquely Enduron, and I've always kind of viewed it as sort of our secret weapon. And here we are on a podcast talking about our secret weapon. Enduron is we're, as you know, an 80-year-old family-owned business that's been in the coatings business, well, for all 80 of those years. We started research in the early 1970s to try to develop corrosion-resistant materials, particularly for the ductile iron pipe business. But it had to do, and that was back when coal tar epoxies were big, and utilizing that technology. So we started developing technologies that allowed us to compete on long-term performance and on user-friendly application properties. Even back then, we knew that saving a contractor time was saving a contractor money, almost irregardless of the cost of the bucket of paint. We also knew that extending the performance of corrosion-resistant products was very, very, very important, especially in the ductile iron pipe business, but really in all of the businesses that we now focus on. So we started this research with a super lightweight pigment that allowed us to significantly increase the PVC content of our products.
That's pigment volume concentration for
that
anybody
is,
that doesn't know
is
that one.
pigment volume concentration, where I sort of flubbed on.
And that's a big deal for industrial coatings because we can only fit so much stuff in the bucket, right? So as we add solid additives to our liquid resins, eventually you run out of space for things you can pull into that solution and mix in there. So finding ways to increase our PVC without monkeying up the flow of the paint or its chemical properties is a pretty important part of the paint making process.
100%. And that's very important for the long-term performance. That's also very important for the contractor. And so going back to bringing value to the asset owners and the fabricators or manufacturers, as well as the contractors who are working with those products. So we found this stuff, ceramic spheres that were perfectly round, so they would flow better, making the paint apply better, whether it's going on by roller or brush or spray application. The unique part that really helped us with the PVC is there are 3 orders of magnitude in size of these ceramic spheres. So the ceramic spheres are lightweight, so makes the product lighter, easier to pump, easier to move. They are round, makes it easier to flow, and there are 3 different sizes, order of magnitude. And the analogy I always like to use is we start filling a room up with beach balls, large round particles. Is the room full when you have 100 beach balls in there? Well, yes, but if you throw in a bunch of golf balls that falls into the interstitial space between those large beach balls, it's more tightly packed. If you follow up those golf balls with a bunch of different size or a bunch of very, very small BBs, they fill the interstitial space between both the beach balls and the golf balls. And we have a pretty cool, we have an exercise ball and a golf ball and a beach ball, or a BB. And if you really look at those, each one is an order of magnitude bigger than the other. So that's what allows us to increase the PVC. They also help with the application properties There's a lot more that they bring to the table too, in terms of reducing permeability, allowing you to build a thicker film, and sort of the overall magic they provide. Since they are inert, they provide better adhesion to the substrate than cohesion, meaning they stick to the substrate better than they stick to the rest of the paint or each other.
Talk to me a little bit about, as we figured those things out and we got the mechanics of how ceramic spheres work in a paint film, that became Protecto 401, which was then launched as a ductile iron sewer liner, and has remained the global leader for that service for a really long time. So I think that's an important part of the ceramic epoxy story, because it allows us to operate so confidently in bringing ceramic epoxy to other environments, because quite frankly, with Protecto 401 since the 1970s, we've had this epoxy in service where we've got sewer pipes, right? We're dealing with H2S headspace, a lot of debris and physical beating that goes on inside those pipes. Yeah, abrasion. And then super long service lives. It's not as though people are yanking these pipes out and doing maintenance coatings on them in any kind of regular basis. So as we discovered all these things, create Protecto 401, it kind of set the stage for everything that we've done with ceramic epoxy since, right?
Very, very much so. Very much so. We started research on the version of Protecto 401 that is now the industry leader in 1979. The first big job we got was in South Florida, Dade County, in 1981. We became the industry leader shortly thereafter because of the performance and because of the user-friendly application characteristics. When I was recruited by my dad to come to work to Enduron in 1997, there was a Protecto 401 video that was 15 years old at the time, talking about the fact that there had been 0 confirmed coatings issues with Protecto. That made me encouraged to come to work at Enduron because of that track record. That was, almost 30 years ago.
Yeah.
And Protecto 401 is still the industry leader in the ductile iron sewer pipe business. And that is one of the most corrosive environments that we try to service. And so for a long time, Protecto 401 was a standalone product that was labeled differently and not broadcast as an Enduron branded product. We started doing that in the late 2000s, 2008, 2009. And since then have tried to use the ceramic epoxy technology throughout our product line for potable water storage tank linings, for power transmission and distribution products, for really anything that needs to have improved long-term corrosion resistance and user-friendly application characteristics, which in my opinion is just about all the products we manufacture.
Yeah, and really ceramic epoxy and how we've used it in other products has set the stage for all of Enduron's growth, but I always kind of tell that story as also being tied to the generational ownership we've had here, because in one sense, David, your father, spent his career developing, deploying Protecto 401 and taking over the sewer pipe market. And I think a lot of the time since you've been in the leadership role, what Enduron's really done is we looked at, hey, if we think we have ceramic epoxy that is a unique material that achieves outcomes no one else can achieve, where else can we use that? And our answers are big public infrastructure, right? So if we really think we got a better mousetrap, we can make assets last longer at a lower cost, we're safer. That's a big deal to us, and we've very intentionally decided to point that at things like power distribution, clean water, effective sewer systems, water treatment plants, big public assets where fighting with corrosion makes a serious human difference for the people that we're serving with the epoxy that we make.
100%. As a small family-owned company competing with much larger publicly traded entities. I've used this analogy in the last couple of days. I feel a little bit like we're a mouse running in a room full of elephants. We have to be quicker, we have to be nimble, and we have to have something that's different. We have something that is different with our ceramic technology. It provides us a unique advantage that I'm super proud of because I've seen it perform in lots of potable water storage tanks in Philadelphia and continue to perform well in ductile iron sewer pipes and work well in manhole replacement products and cementitious repair. It's really neat stuff.
So let me talk a little bit about that, the science of why this stuff is different. One thing, anybody that hangs out with Inderon folks hears the term ceramic epoxy nonstop. That's part of our job. But a lot of people don't really understand what we mean by that. We get a lot of comments of like, ceramic, are you talking about my coffee cup? What is this stuff? And so I always think it's important for us to break down that when we make coatings, there's a few different key ingredients there. The names usually come from our resin category if we're making an acrylic, an alkyd, an epoxy, a polyurethane, and those are liquid components. But then we add dry goods to those when you make paint, right? There's going to be different reinforcing material, color, pigments, adhesion promoters, things that we add. And when we talk about ceramic epoxy, what we're really talking about is those three grades, three size magnitudes of ceramic spheres that for each of our products is a specifically engineered blend that we've come up with of the right number of spheres, the right volume to the liquid that's there so that all this stuff comes out as a coating that properly flows, adheres, and meets all our testing requirements. But as we launch that and discuss what it's made of, it's really important for people to understand the spheres that are going into the liquid is where the ceramic terminology comes from.
The term ceramic epoxy comes from the hollow ceramic spheres that we use as part of our pigment package. And I'm kind of smiling here because I remember very well the very first presentation that I made on PermaClean 100, 100% solids, ceramic epoxy for the inside of water tanks. And it was to Aqua PA up in Philadelphia 15 or so years ago. And a good friend of mine in the audience, first question out of his mouth was, I hear the term ceramic and I think about china. I think about a coffee cup or a saucer, and I think brittle. And that's what people think about when they think about ceramic. This stuff doesn't go in a kiln. This stuff is perfectly round ceramic spheres that are part of the pigment package that go into our product. So immediately what I worked into my ceramic epoxy presentation was a picture of PermaClean 100 on a mandrel bend, which is a common test for those in the paint business, where you paint a steel panel, a Q panel, and bend it 90 degrees, and there was absolutely zero cracking along that bend. And people see that, and they're like, oh, okay, very flexible, not brittle.
Yeah, I always tell people, we show them that mandrel bend where we put a 90-degree bend in it, and my line is, if your structure moved more than 90 degrees, paint is the least of your problems. Generally people think of epoxies as not handling movement, being too brittle for things like that, but with ceramic epoxy in our product line, we've seen a lot more flexibility than other products and really don't have that problem. Another thing I'd love to visit on is the notion of what I refer to as wet film versus dry film properties. We've talked a lot about ceramic epoxy and why we love it, but I want to specifically connect the dots of why should a contractor or applicator care? What do those spheres do from there? And then separately, it's sort of a different list when we talk about asset owners who are investing in the dry film, the long-term performance of how long something's going to last. And we really have two good answers for why each of those parties should care. When we talk about wet film, that's the applicators, right?
Yeah, that's what I was going to say. Well, since there's two of us, why don't we break it down?
Yeah.
Right? Why not? Your background is as an applicator. You have lots of experience painting. Why don't you talk about some of what we deem wet
Yeah.
properties, and what are those advantages?
I think a great place to start with that is another Andyism that I say all the time is every year I've been in this business, paint has gotten harder to successfully apply because of regulation, restricting the chemicals that can be used, tighter QC parameters, et cetera. Being a successful paint applicator takes more training, more effort, more awareness than it ever has. And part of that, I think, is on the paint manufacturers. We have a specific role if we want to help this business be successful and deliver successful, complete projects to people. We need to make this easier to do in the first place. We can't just continue to always shove more technically difficult technology onto applicators. So that's where these wet film properties come in. We've got specific goals that we track, we work on, we develop to make sure these products are easier to do right in the first place and easier for applicators. Weight of these ceramic spheres has a ton to do with that. So if I'm an applicator, that means I've got to get the paint out of the bucket onto the surface looking like it's supposed to. That's going to take somebody's energy, whether it's a bucket and a roller that you're moving around or a spray pump. And when you lower the weight per gallon of this film significantly, it gets a lot easier to move. So with all these ceramic epoxy products, we're able to forego the use of thinner. Because we've got such good flow to our products, we don't have to field add solvent to this stuff. If we do need any viscosity adjustments, we can do it with really reasonable temperature management of the material. We're able to build more mills with ceramic spheres there. One analogy I often use is think about overcoating and maintenance painting. As we stack things up, they get more stress. I always say if I hold my arm out, and I could do this all day, but if you start stacking weights on the end of my hand, I feel the stress back here. And the same thing happens in a paint system. As we stack more layers on, we stress that primer to steel interface. And with ceramic epoxy, where we're adding less weight and less of that stress, we can build more mills before we cause a problem there. So for applicators, that might mean that I get a tolerance of 5 to 30 mils instead of 3 to 5. And when we're talking thousandths of an inch with a hand tool, that's a world of difference.
A lot wider window of opportunity.
Yeah, and the same thing, that's true of a person or a piece of mechanical equipment, right? If it's easier for the guy to brush and roll and move this stuff or even carry the physical bucket around, it's also a whole lot easier for that pump to move it. So one thing that we get constant great feedback on from applicators is they're like, man, I can run your stuff 5 times as long before I rebuild this pump. My spray tips all last longer. It doesn't tear my guys up as bad moving this stuff around.
And I think that has to do with the size of the spheres as compared to other aggregates or other pigment that we add to paint, like zincs or silica, which are angular and jagged.
And heavy.
And they're running, they're tearing up gaskets. They're blowing out tips. They're messing up everything they come in contact with, which is very different than those hollow ceramic spheres.
Yep. And I mentioned solvent and heat. Those are two of the biggest safety hazards that a coatings applicator is going to deal with in the field. So, step one, right, if we're trying to keep people safe, is just eliminate the hazard. When we can take solvent out of coatings, move 100% solids, and still get all the performance we want, that's a massive upgrade for the guys in the field. And then you take it a step further. Let's say we do something like eliminate their need for a plural component pump. Because our material can spray so well and go through a single leg pump, think about the difference there, not just in cost and man hours, number of people needed, the training those folks need. Everything about that job site got much easier, even though the owner's getting delivered the same mills, the same protection, but they're going to end up with a better cost because it's so much easier on the applicator.
Well, I think of a funny joke when I got into the business. It was with paint, it's like thin with alcohol. That's what we kind of talked about. But I was also told that it's not paint until you add solvent, until you add thinner. And that was just the norm in the late 90s. You'd activate the paint and pour in 2 or 3 glugs of material. Now we don't have to do that.
And frankly, I think that still persists. There's still a lot of applicators who view solvent as a necessary addition. And again, I would say I sort of blame the paint manufacturers for that. the technology was not manufactured and delivered to the market in a way that proved the opposite. And now that we have these coatings where we're successfully doing this year after year without solvent additions, without heating the paint up to 140 degrees or any of these crazy numbers other folks work with, to be clear, with our Enduron ceramic epoxies, these things are flowing at 85, 90 degrees. We're not asking applicators to heat this stuff up super hot. You know, I see competitor applicators with a welding glove on while they hold the spray gun because they got to get this stuff so hot to flow. And those are all good examples of adjusting those wet film properties might not even enter the mind of the asset owner or the specifier, but they mean the world to the applicators.
100%. And I think about when we first rolled out Mortar Chem, a video and a mean letter we got had to do with the weight per gallon. And that plays itself in a lot of ways because guys have to carry buckets into aeration basins. You have to pump it up an elevated water tank. You have to move it from the flatbed to the pickup truck and the pickup truck to the wherever you're doing the work on the job site.
Yep.
That's wear and tear on the painters. Then you start talking about something that you're troweling on a surface. That's wear and tear on the guy's shoulder.
Yeah, and in these cases, to be clear, we're talking about like 50% weight reductions. These are big, impactful numbers. So as people hear us talk about this, it's not as though we're saying, oh, we made it 1% lighter, you should care. These are real differences that are noticeable to the applicators and the impact they have on equipment.
Yep.
So in addition to that, talk to me about dry film properties. You mentioned adhesion, cohesion earlier. I think that's a big part of this story, right?
So I really think, I think there are a lot of advantages, but I really think that is sort of the secret is this paint sticks to the substrate better than it sticks to itself. The adhesion is better than the cohesion. And people are like, well, what does that mean? It means when you have a small pinhole and a rust cell starts, a corrosion cell starts, the pinhole can be there for any reason. It's a rock thrown up against the outside of a leg of a water tank. It's a pinhole because somebody missed something in application. Corrosion cell starts. That corrosion cell will grow as it will take the path of least resistance. And as iron becomes iron oxide, it increases in size significantly. And if the paint adheres better than it sticks to itself, then the point of least corrosion is up. If the cohesion is better than the adhesion with a vast majority of our competitors' products, there's undercutting. So the corrosion cell takes the path of least resistance, and a small problem becomes a big problem before anybody realizes it, and then you have paint coming off in sheets, and you have a large issue. If you have a self-capped corrosion cell, not that big a deal. Easy correction, easy fix with an annual touch-up.
And one way I always try to connect this whole cohesion, adhesion of coatings conversation to just normal, anecdotal, what we've all done in everyday life, I always use the analogy of trying to pull a price tag off something you bought. Like if you imagine you go to the store, you bought a mirror and there's a price tag on it. If I go to peel that price tag off and it all comes off as one piece and there's no glue on the mirror, that's great, right? I feel good about that. It was easy to take off. But what that means is the cohesion of that sticker was greater than its adhesion to that mirror. So when I put stress and pulled it, it stuck to itself and remained a sticker more than it wanted to stick to that surface. That's great when you're peeling off price tags. Yeah. It's the exact opposite of what you want your protective coatings to do. So we imagine the opposite scenario, right? We've all done this where you go to peel the price tag off and the top layer of paper comes off and there's still a whole sticker there and you didn't get any of the glue. And you pick at it again and you get a little more paper. And 5 minutes later, maybe the paper's gone and it's still covered in glue and you're trying to figure out how to get that off. That's because it's got better adhesion than the cohesion of that sticker. And when we can create that with protective coatings, play this out, like in our sewer pipe, right? We're getting the heck beat out of it. We've got debris, we've got corrosion cells growing. And when the coating is willing to break in itself and leave intact protection on the surface rather than peel off in a sheet, we see these fantastic longevity results that don't create these spreading undercut failures.
Phenomenal description, and I like this sticker analogy.
Yeah.
But it really makes a difference in handling things like ductile iron poles that are manufactured and painted in one place and loaded onto a truck, transported and installed in another place. That is, moving around heavy things like that, or like galvanized poles, or any kind of steel pole. It's not exactly handled with kid gloves, with straps and chains, loading trucks, unloading trucks, moving these things around. They get banged up a lot.
Yeah, they get drugged quite a bit.
Well, and if all the paint comes off, then why are we painting them in the first place? Or if a lot of the paint comes off, and then you've got an undercutting problem because they're like a sticker comes off, that competing technology. Yeah. It is a big advantage that not many people think about, and is probably the biggest, but not only dry film advantage. You had mentioned earlier about film build, and film build, I remember when I got in the business, and I once again sound like an old man here, but 4 to 6 mils was a thick film coat of 54% volume solids materials. Now we're making 100% volume solids materials, and we're applying it 10 times that, 50 mils in one coat. Heck, we're even making a ceramic epoxy now where we can put a 1/4 inch, 250 mils on a vertical surface. And it's because of the hollow ceramic spheres and some other chemistry that allows us to do that. It's not just the ceramic spheres, I know that. But building that film thickness is a significant advantage.
Yeah, I mean, epoxy at the end of the day is about barrier protection. So when we can offer more barrier without creating additional application equipment or requiring more coats out of the applicator, when we can do that without adding cost, it's a significant benefit to the, again, wet film and dry film, the applicators and the acetone.
Yep. The other one, the other dry film advantage that I always like to talk about is permeability, and this is reminds me of the old joke that involves beer, because I like beer. When you fill up the room with beach balls, golf balls, and BBs, and you've got that room full, and it's easy to get on a vertical surface, and you have a thick film, when the epoxy, if a particle of water, one drop of water gets through that substrate, works its way through the epoxy, which it inevitably will.
This is something we can measure. It's called a perm test. Moisture vapor permeability is a metric of every liquid applied coating on Earth, and it's an ASTM test you can run to determine what is my moisture vapor transmission rate on this film.
But what I've always said is that drop of water hits a beach ball, and it has to go around the beach ball, and it's working its way around the beach ball. Then it hits the darn golf ball. It's got to work its way around that. Then it hits 3 BBs, and it's got to work its way around each one of those, and voila, there's another beach ball. So it makes a thick film of ceramic epoxy play like it's thicker than it is.
Yeah, it's sort of like you get 40 mils of protection out of 20 mils because anything that tries to move through there has to take this circuitous path around all those fillers that we've added.
Exactly. And that's why that's part of the magic of Protecto 401 and its longevity. That's part of the magic we've experienced with Permaclean 100 and its longevity. It really is something, and I said it earlier, I felt like it's sort of our secret weapon, and it's a darn good one.
Yeah, and the cool thing about being at Enduron now, it's a lot of fun with the chemistry team we've got. We featured some of them on the podcast here, so everybody knows we got some good brains in the background, and now we're in a position to add our ceramic packages and design them for a lot of different technologies. We've talked a ton about some of our current epoxies, but I want to make sure everybody understands that we have also we've made innovations in a bunch of different directions, one of which which being our first thin film ceramic epoxy, where we've finally got, we were able to source ceramic spheres and make a sphere package small enough for us to produce quick dry shop primers that can be used on steel or concrete. We've also moved forward in the power business, where we've used alkyd coatings that are ceramic reinforced to benefit alkyd technology that's used there. So this is really opening up for us, where almost regardless of the resin technology we're using, we're able to engineer ceramic sphere packages that benefit the product. And as a result, sort of across Induron's product lineup, we're able to push our results up a little higher, make those wet film and dry film properties better. And it's, to your point about it being our secret, it's really become our primary differentiator, regardless of the market or coating. Our ability to understand that film and how that will translate to wet and dry properties is sort of what's making it a lot of fun to work here lately.
Well, think about it as vastly different as the markets are that sewer pipe, the applicators, and the inline users. Power transmission and distribution, maintenance, coatings, extremely different. Potable water storage tanks for new tanks and tank repaints, almost different markets in and of themselves. And then concrete repair in manholes or wet wells or water or wastewater treatment plant. Very, very different markets, but they all are similar in the fact that they need paint that is easy to apply correctly, and they want stuff that lasts a long time. And if this stuff can last in a ductile iron sewer pipe for 50 years, it's going to work on an aged power transmission structure, or a potable water storage tank, or a rehab in a manhole.
Yeah. All of those environments are more benign and easier service than what we put Protecto in every day. So it's, one way I always talk about that with asset owners is we've had Protecto in the ground handling their worst environment for 50 years. And really what we're talking about with owners today is connecting the rest of those assets to the same protection and technology that they've enjoyed with sewer pipe for years.
Yeah. Yeah, it's proven technology.
Yeah.
I always say Protecto's the gold standard for ductile iron sewer pipes.
Yeah.
And that's a very aggressive environment, and one that we do pretty well in.
So I think kind of our closing message for everybody here is if you're an applicator, we'd love to come see you with ceramic epoxy. And I always say, don't trust me, right? Make us demonstrate this stuff. We want to show you how it sprays, put it in your hands. The same thing with engineers, with asset owners. Our goal is to come see you, to find projects where we can put this stuff on and prove what we're saying. At the end of the day, none of these comments about ceramic epoxy matter if we can't translate it to success in the field and delivered projects. So sort of our ask to everybody is, hey, drag us out there and give us a shot to prove what we're talking about. Thanks for tuning into the podcast today. We'll be back with another episode and more great stuff about paint shortly.